Hey Adam, sorry the core meeting went a little over. All right, let's see. We've got two new PRs this week, both of them related to AVX2 encoding for doing buffer list encoding and decoding. The claim is that it's about twice as fast in some cases and 20% faster in others. So that's exciting. Let's see. What else do we have here? Nothing closed that I saw this week. RocksDB, we have had some issues with data corruption and potentially, I don't actually know if what we're seeing, it might actually not be due to RocksDB itself, but there's a proposal to update it to 6.8.1, which I greatly support given some of the changes that were in the history. So that is being looked at. And then Adam, there's your PR here that looks like still going through testing.
Not exactly.
Oh,
Apparently something else destabilized testing, and Neha just wants to wait for that to get sorted out exactly what is attributable to that to merge my thing in, and then she says that should be doable within the week.
okay, good deal. I'm super excited to see yours go in. All right, let's see what else do we got here. This optimize the lock Blue Store writing process. I should probably dig into that. I don't know that anyone else is going to, and I'm scared of the locking in Blue Store, but theoretically that offers a nice performance improvement if it actually is safe. I think actually I can punt on this for a little bit because Kifu needs to run it through Teuthology. But if it passes Teuthology, then probably should actually dig in and see if it really looks safe or not. If it fails, then it's easy to just say nope. Okay, what else? Sam's initial C-store work continues to get review and updates, so that's in the works. Good. Igor's memory reduction for the O-node PR failed tests. Kifu put in a note in the pull request where it looks like it's failing, so hopefully Igor can get a chance to look at that. That would be a really nice PR to get in here early in the next cycle. Lots of stuff with no movement. I actually didn't make it through all of them, but usually the stuff at the end doesn't get updated anyway, so I don't anticipate there was a whole lot there that we missed. I know closed PRs for performance that I saw this week, but it's a little bit of a slow time at the moment, so not terribly surprising. Okay, there are two things on the discussion list today that I wanted to bring up. Oh, good, Adam, you're here.
Okay.
Good deal. I was actually just wanting to bring up your work on the Blue Store memory growth. So, do you want to talk a little bit about what you found, or I can recap if you want to, either way.
Well, Mark, I think you will do it better than me.
Okay, no problem. So lots of users are reporting that they're seeing buffer and on-memory growth on mailing list, and I think, Adam, you are also seeing memory usage growth during tests with compression enabled. And it looked to me like in the work that you just did yesterday and today, that you were seeing that when objects are pre-created but not yet filled in, the ONode's memory that's used is very small due to not really having a whole lot of shared blobs or other things. But that then when you actually fill those ONodes in with data after they've already been cached, then the memory usage of all of those other things can grow quite large. Is that correct?
I knew that you will explain it better than I could.
Oh, does it sound correct though? I guess is my question for you.
Yes, exactly. That's the issue. The objects start with very low overhead, but then the overhead grows very quickly. The other question correlated for me for next investigation is why do we need about 1 MB to store metadata for 32 megabyte objects? That's like crazy stuff. But I'm working on this now.
Excellent. I agree 100%. It's madness. It should not take one megabyte of metadata for a simple 32 megabyte object. Yes, I'd be very, very curious to see what you find in terms of which of those things is taking up so much space. If it's shared blobs or extents, or I don't know if there's anything else possibly as well.
I promise I will get with some numbers when I have them.
Cool. So that's very excellent work, Adam, because this is very, very good to find out. So Adam, you have your proposed fix. That's very simple and very, very convenient. Just to do the trim in the mempool thread. I'm a little nervous about doing it there. That's kind of what we used to do, is we trimmed periodically in the mempool thread. Potentially that's maybe why we didn't used to see it. And now we trim every time a new thing is entered into the ONode cache. And that lets us trim when we already are holding the lock, and also trim in the different TP-OSD-TP threads rather than in a single thread like that. The reason I'm a little nervous about doing the trim in the mempool thread is, one, I think that the way that your PR would implement it, it would only do that trim once every second or 5 seconds or something. So you could still potentially have a lot of growth very quickly. It would get rid of it eventually, but you could still have temporary spikes. And then the other thing I'm a little bit nervous about is that if we were to increase the frequency of that, we might be back in the same situation we were in before, where we are grabbing that lock and doing those trims very often, and it impacts performance. So
okay. The first thing, I guess that what you say is factually incorrect, because if you add some object to some cache shard, then this value max will be tested and the trim can occur. The problem stemmed from that there was no traffic on ONode cache shards, and then they just stayed big, and I mean bigger in a size but still the same amount of objects. So that's not the case. I mean, but that may be a problem with efficiency when doing periodic trimming, but you will not get a much spike unless you will grow the metadata for objects you have already cached very, very quickly. So that's the possible avenue of growth.
And that's what's happening, right? Is that the object count is staying the same, but because you're filling things in, these pre-created objects in later, then you have the growth in buffer anon, right?
True. But from my observation, it cannot grow very fast.
Okay. That was what I wasn't sure about, was whether or not you could end up in a situation where between those trim cycles, you could have significant growth.
I don't think so, because these all are blue store structures and there is a lot of them. So you just had to process a lot of new, in my case, compressed blobs, shared blobs, stuff like that. There is a limit how fast you can generate.
Okay. Is it possible? I guess my question would be, is it possible for us to do a trim when we grow those structures? Like if we know that we're going to be increasing the size of structures, if we should trim then, especially if we're already holding the lock. Does that make sense?
Of course, well, yes, it makes sense, but this defeats the original purpose, not to actually touch all nodes when you only operate on data. So you would have then, if you're operating on like shared cache, data cache, buffer cache, then you will have to jump suddenly to O-node cache and do some poking there, I guess. Or
Okay.
if we put it in some lower level of blue store, then of course, if we change like extent map of O-node, then we can also make proper O-node cache, chart cache tick. But yeah, that's still possible.
Okay. Yeah, I haven't looked at where it would be convenient to do something like that. You've probably looked at it more recently than I have now. But if we have an opportunity to do something along those lines, I think it might be worth trying as opposed to doing it in a mempool thread like this. But we can see.
Okay, I will come through code and try to find some candidate places for periodic but still not high frequency check.
Sure. Okay, cool. Yeah, again, Adam, thank you so much for looking into this, because it's very impactful for many users. So it'd be really good to fix it. Good job.
And thank you, Mark, for our yesterday talk. Without it would take much longer.
No problem. Glad it helped. Okay, so the other topic I wanted to bring up today is this is good information, I think. So there's been a lot of discussion right now inside Red Hat about whether to run multiple OSDs on one device, and if we should be building tools for doing partitioning in such a way to make that very convenient for end user and all of these kinds of things. So one question that came up is whether or not it's really beneficial to do this still. So over the last weekend, I ran a number of tests looking at that, and the end result of this is that much faster in the testing I did on the platform that I did in Octopus and Master than we were in Nautilus. So I pasted some of the results into the chat window there. In Nautilus, we saw very significant gain with running multiple OSDs on an NVMe device, two OSDs on one NVMe device. In all of the tests, it was better but the results range from 10% better up to around, in one case, 80% better for random reads, small random reads. In Octopus and Master, it's much more mixed. Our single OSD case is much faster than it used to be, to the point where in many cases now, you're actually, in these tests anyway, it was faster to run a single OSD on an NVMe device than it was to run multiple OSDs on an NVMe device. And there are a couple of reasons for that, I think. The cache refactor from last summer, I think, played a big role in some of this. And then Majian Peng had a very good PR in Master that it's very simple, but we do notify all instead of notify one in the shard op work queue. And I think that's a large part of the reason why small random read performance continued to increase in Master, to the point now where it's faster with one OSD versus two OSDs. We previously just were not making good use of all the different threads. We weren't waking them all up. We were only waking up one. So it's interesting. I'm getting feedback from Intel that they are not seeing the same kind of improvement that we are on our tests. So we do need to do some more investigation into why they're seeing regression actually with Octopus. But at least here, I'm fairly confident that these results are real. So the good news is that I think we have made some real improvements here. So that's really all I had. Any questions on any of this, or comments or thoughts? Okay, good. Oh,
so this is Danny Abukalam. I've just joined midway through this call. It's the first time I joined, so I'm probably missing quite a lot of context. But these test results look really interesting. I was wondering, is there somewhere online I could find kind of documentation or information about the process you took or the tools you used to run these tests and benchmarks?
Sure. I can tell you. This was run using CBT, so that's kind of our general test framework for running benchmarks that we use anyway. And CBT can run a couple of different benchmarks. In this case, it was FIO. Are you familiar with FIO at all?
I am, yeah. And I've had a brief look at CBT, but not in too much in depth.
Okay. So all CBT really is a tool that then goes through and runs a combination of different benchmarks with different parameters. So you define in YAML kind of what different parameters you want to run with, and that will run through a bunch of different tests that way. FIO already can do some of this itself, but CBT is kind of a more generic way to do this across different benchmarks and run multiple benchmarks. It can also set up a cluster for you if you desire. So in this case, CBT built the clusters, but a lot of folks actually will run it in a mode where it will run against an existing cluster. That's like, for example, what some of our upstream teuthology tests that run CBT do.
Okay, that makes sense. And if you were to look at doing testing over S3, what's the preferred way of doing that with CBT?
So there's two different things you can do. CBT can launch and run CosBench, but CosBench is really almost its own framework, right? It's very complex and it does a lot. So some people have done that, and that can work. Although I think a lot of people will just run CosBench on its own, as that's also totally fine. I also wrote a benchmark called Hot Sauce, actually, that is a much smaller, kind of simpler benchmark than CosBench is, and is kind of designed to run from the command line. And CBT can also run that.
Cool. I ran something brief with hot sauce as a test, but I can't really comment intelligently on it. I was just playing around, but it looks like a very cool
sure.
tool.
Oh, thank you. Yeah, it's the goal with it was more or less to be able to run tests in a much more kind of convenient way through external automation. CosBench just can be a little bit rough trying to do that. So
Yep.
if you
I'm familiar with the pain of CosBench.
Sure. Yeah. It doesn't help too that that the original authors have moved on to other projects. So it's I think I don't know how much maintenance is getting these days.
Yeah.
So if feel free to try CBT if you'd like. It's not the most documented tool in the world, but people are there. Actually, the Crimson team has now been using it for nightly regression testing, so it's getting a little bit more love from multiple people now. So hopefully we can make the documentation a little better too.
Cool. Yeah, no, that looks great.
Excellent. All right. So the only other thing I want to bring up myself this week is Igor, you gave a really good overview in the core meeting today about some of the things that you're looking at with data corruption with RocksDB and the change to revert to always using the buffered IO, BlueStore buffered IO disabled setting. Is there any chance I could get you just to recap what you've been looking at? I don't know if you're trying to talk or not. Your mic is muted.
Yeah, sorry. So you want me to repeat my overview, right?
Yeah, if you don't mind. This is really good.
Okay, so just a general overview for everybody. Yesterday we got a couple of complaints at the users mailing list about data corruption in write-ahead log of RocksDB. And also both cases were happened after upgrade from Octopus 0.1 to 0.2. And at the same time, Niha reported a similar issue in QA run in master. And finally, I managed to reproduce it locally as well. And after some investigation, which is not completed yet, but looks like two recent modifications triggered this issue. The first one is disablement of BlueFS buffered IO, which results in asynchronous IO path coming into Ceph. And the second modification made a while ago is pre-filling write-ahead log with zeros if pre-extend val is enabled. And it looks like this causes some overlapping IOs running simultaneously, and looks like they might be applied in random order, and which causes some data corruption since earlier writes comes later. Actually, I'm trying to reproduce that in a simpler unit test. And if it confirms, we'll need to introduce some IO wait after such a prefill. Actually, we have a sort of it for some other stuff, and perhaps we'll need the same for this case.
Igor, why was it okay when we had buffered IO enabled by default?
Because it goes via different write path.
Did that different write path, did that then guarantee ordering?
Looks like that.
Okay. And now that we're doing direct IO, we don't. Interesting.
Well, as I said, that these are preliminary results, but well, I can't explain why I'm getting 32K of zeros instead of valid data in the log. And I checked if we pass wrong buffer and things like that, but it's not the case. But definitely I can see multiple running IOs for each reproduction. So I think that's the case, but I haven't proved that 100% yet.
Sure. Thank you for working on it. This is a tough problem, and it's good that we fix it. The original reason why we disabled BlueStore buffered IO was because it was causing significant problems with RGW performance, where we were actually seeing that we were digging into swap oddly, even when there was significant memory available, and we didn't really understand why. So we switched back. Igor, do you think we should revert that change and go back to buffered IO?
No. At this point, I think it's rather pre-extending write-ahead lock, which actually causes the issue. So these modifications on buffered IO, they just made it visible, but that's write-ahead lock pre-extending stuff, which is 100% correct, I think.
So I know that I'm pretty sure that we backported the buffered IO chain. Do you know if that other PR that you had mentioned ever was backported to Nautilus?
Sure about Nautilus. I didn't. Well, Adam, maybe you can comment on that. Well, the last fix on refilling write-ahead lock was yours, as far as I remember.
Yes, this is true. I have been touching refilling. I would have to revise it because I don't remember correctly, but it came out as a fix for some problems I had when actually multiple times changing RocksDB sharding on the same volume. Without that pre-extending, it almost always failed. So I would be cautious to disable that part.
Actually, the question is rather if we have pre-extended write-ahead lock enabled in Nautilus right now.
I don't know.
Okay, I think that's easy to verify.
Yeah, just a little bit nervous about whether or not we have introduced this into Nautilus, just because that could cause a lot of frustration for users. Octopus already is a problem, right? But it'd be good to know if it's also Nautilus.
Give me a minute, I'll tell you if pre-extended vowels are enabled in Nautilus.
Sure. Adam, sorry, I'm trying to remember. I vaguely remember when you were talking about this back when you were working on it. But what was the reasoning for that PR again?
The reasoning was that I had a stress test that has been changing RocksDB sharding schema, and the problem was that if a device was not fully reinitialized to zeros, just reused as it was, sometimes after restart, BlueStore, basically RocksDB, couldn't pick up its write-ahead logs and continue. It had errors there. So that was the reasoning. But never I could repeat the problem if I had always, in all tests, the same set of column families. So it was like some change in data structures, in amount of write-ahead logs. I don't know what, but the trigger was changing amount of column families in RocksDB.
That was the only case where it caused the problem, was when you changed the number of column families?
That was the trigger that I had to make the fix.
Okay.
So Mark, back to your question about Nautilus, I can see that BlueFS pre-extend val files is disabled for Nautilus, so hopefully that's not, so there is no such a bug in Nautilus. Well, maybe bug is there, but by default it's not enabled.
Okay, well that's good news, right?
Yeah.
And Adam, that option, this BlueFS extend wall files, that's only needed when we change the number of column families for it to be safe? Is that my understanding?
No,
right?
the reasoning, the original reasoning for that was that it was to speed up, to omit adjusting size with each write to new write-ahead log. So we had a larger write-ahead log and just appended the data, never bothering to update BlueFS log that contained metadata with size. So that way we were a bit faster. That way we made it more alike for as it's in normal RocksDB operation, when RocksDB reuses previous write-ahead logs and just appends data from the beginning. So that's it.
Okay. Yeah, I was just starting to look through some of this again. Okay. All right. Well, yeah, good job investigating this, Igor, and definitely maybe let us know what you see.
Yeah.
And Igor, please ping me if you find that there is something I can valuable contribute to that.
Yeah, sure.
All right. That's all I've got for this week, guys. Anything else anyone would like to bring up? All right. Well, thank you very much for coming, and have a great week, everyone.
Thank you.